Okay, happy Friday, y'all. I am recording for you your notes so that way we don't fall behind. So today we're going over 8.3. These are going to be special right triangles. So, excuse me, we learned all about triangles, and now there's going to be some triangles, they're a little bit more special than others, right? Just because they're common, and they show up a lot, so there's like patterns that we notice with them. And then this is going to involve the radicals that we've been learning about, but nothing too crazy. They're actually all going to be very similar to each other. So and the numbers are pretty small. All right, so the first special right triangle that we're going to talk about, and the only one we're going to talk about today, is the 45, 45, 90 right triangle. And it's called a 45, 45, 90 triangle because that is the measure of its angles. And since two of the angles are the same, that tells us that the two legs of this triangle are the same. And the hypotenuse is going to be different, obviously, right? Okay, so here, that is going to be your perfect triangle when you cut a square, right, diagonally, right? You got two 45, 45, 90 triangles there in your square. So that's why this one is special, because it's very common. It comes from the square. Okay, so we can use Pythagorean theorem to find the relationship among the sides of a 45, 45, 90 right triangle. Okay, so there is a theorem, right? Some shortcuts, so we're not having to do long math every time. Some shortcuts or a pattern that's common with this one that we're going to go over is the legs are congruent, and the length of the hypotenuse is always going to be radical 2 times the length of the leg. So in a 45, 45 triangle, if the leg is length L, then the hypotenuse is going to be the length L radical 2. So whatever the number is plus a radical 2, right? So if the legs are 2 and 2, then the hypotenuse is going to be 2 radical 2. Okay, so let's go ahead and do a few sample problems here together so we can kind of wrap our heads around it. Okay, so here, if my leg on this side is 6, I know the leg on this side is also going to be 6. And then my hypotenuse over here is going to be 6 radical 2. It's always a radical 2, guys. It's not going to be a radical anything else. That's just the shortcut. That's the rule here, right? So if we know a leg, if we need to find the hypotenuse, kind of a shortcut, not having to do Pythagorean theorem, we just know, oh, if I just multiply it by radical 2, I'll have my answer. So even if they're asking for the answer in decimal form, you can put 6 radical 2 in the calculator and boom, you have your answer. Saved yourself the trouble of having to do Pythagorean theorem. Now this will only work for your special right triangles, in this case the 45, 45, 90. Okay, so this next one, they kind of trip us up a bit because they put the radical on the legs. Okay, so remember the legs are still L. This is still L radical 2. So we're multiplying it by a radical 2. But if my leg already has a radical 2, so it's 9 radical 2, we're going to just multiply it by another radical 2. And we learned that with multiplying radicals. And since this is the same, right, this is a 2 inside and this is a 2 inside, they're going to end up kind of canceling each other out, right? And they'll just give us a regular 2. Or if you go ahead and multiply them out, it's the same thing. It'll be 9 radical 4, and we know the square root of 4 is 2. So it equals 9 times 2, which is going to be 18. So in this case, x is just equal to a whole number 18. All right, moving on to the next one. All right, this is another simple one, just like that first one. Okay, the leg is 9. So my other leg is also 9. And the hypotenuse, not having to think or do too much math, is going to be 9 radical 2. All right, so those are my answers right there. Okay, so let's go ahead and pause it here. I want you guys to try these next 3 out on your own, check them with each other, and then we will come back and check them together. Ready, go. All right, bringing it back, let's check them. Okay, so for this one, this was another simple one. All right, we've got our leg here, that's 4, so I know our other leg is also 4, and the hypotenuse is 4 radical 2. All right, if these are your answers, you nailed it. Good job. All right, for the next one, we only need to find the hypotenuse. They're already telling us, hey, both legs are 5. Cool. We know our hypotenuse is going to be 5 radical 2. And that's it. Not a whole lot of work needing to be shown for these ones because it's a shortcut. All right, so this one we do have to do a little bit of work. All right, so 7 radical 2 is on the leg. So the other leg is also 7 radical 2. Okay. Now, again, remember, or we can just remember it's going to be 7 times a regular 2, but if we don't remember that, it's 7 radical 2 times another radical 2, which ends up being 7 times a normal 2. The radicals canceled each other out, and that equals 14, right? So our hypotenuse here this time is 14. All right, moving on. Next example. Okay, so we can also work backwards, right? So using the theorem to find the lengths of the legs, the triangle given the length of its hypotenuse. So what we did to get from a leg to a hypotenuse was we multiplied by radical 2. Well, the opposite of multiplying by radical 2 would be dividing by radical 2, right? So it's nice when the hypotenuse already has that radical 2 on it, because it just kind of goes away, right? So if the hypotenuse is 5 radical 2 and I divided it by radical 2, those cancel, and my 2 legs would be 5, right? Or if we just kind of recognize the hypotenuse already has that radical 2, we just take it off. Our legs are going to just be that number, right? So 5 and 5. All right, the tricky part is this one, right? Where they give us the hypotenuse, and the hypotenuse does not have a radical on it. All right, so let's just kind of work through it. And it'll be the same every time. So once we catch the pattern, we won't really have to do the work every time. So here it's 12 divided by radical 2, right? And remember, we learned in fractions with radicals or dividing with radicals that we don't want to keep the radical on the bottom. So I'm going to multiply by 1 in the form of radical 2 over radical 2. So we end up getting a 12 radical 2 over a regular 2. Okay. But then, wait, there's more. Right here, 12 can be divided by 2, right? So half of 12 is 6. That radical 2 is still there. So it's a 6 radical 2. Okay, shortcut, or the pattern if you want to catch it. Anytime you have a number without a radical as the hypotenuse, divide that number by 2 and put a radical 2 next to it. That's all we really do. Right, half of 12 is 6, and then put a radical 2 next to it. Half of 12 is 6, put a radical 2 next to it. The only time this is ugly is when they give you an odd number instead of an even number, so it doesn't divide by 2 nicely, and that will happen. All right, so let me do a quick little example over here. Let's say they gave you 15, right? So rude. Okay, you would just leave it as 15 radical 2 over 2, right? You're still dividing it by 2. Putting a radical 2 on top. 15 radical 2 over 2. That's what you do for those ones. Okay, so go ahead and try a couple out on your own, and we'll come back and check them. Ready to go. Okay, so let's go ahead and check them. This one, again, is one of those ones that kind of works out nicely since the radical 2 is already on the hypotenuse, like it's supposed to be, right? So then our 2 legs are just going to be that number 17 without the radical 2. Okay, so if you put 17, awesome, you've got it. Next one, it was nice to us by giving us an even number. So if you went to the shortcut method, we just know we divide it by 2 and put a radical 2 next to it. Okay, or if you forget, just divide it by radical 2, and then you're doing the extra work here, just going da 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 da, and then you end up with 18 over 2 with a radical 2. Okay, again, we can't leave it like this because 18 can be divided by 2. So half of 18 is 9, and then put a radical 2 next to it. And that's it for the 45, 45, 90 triangles. right? So we will see occasionally some word problems, right? And then sometimes you'll get regular problems, but you'll notice, hey, this is a 45, 45, 90. I know a shortcut for this, and save yourself a little bit of time, right? We're always trying to work smarter, not harder, okay? But if you forget the shortcut, you can trust in your ways. You would just be doing Pythagorean theorem and then simplifying your radical if they wanted the answer in radical form. But like, you know, if there's a shortcut, we want the shortcut, right? Okay, so the next one here, it says a kite string is 300 feet long. Okay, so if they're saying the string is 300 feet long, that means this line right here is 300. Okay, from the kite to the ground, the string makes a 45-degree angle, it's already there, with the ground. About how high off the ground is the kite round to the nearest foot? Okay, so they're asking for this measurement right here. Okay, so that's my x. Okay, so if we see it, this is a 45, 45, 90 right triangle, and my hypotenuse is 300, right? So I'm dividing by 2 and putting a radical 2 next to it, right? Because I'm working from the hypotenuse back to a leg. So 300 divided by a regular 2, and then put a radical 2 up top. 300 divided by a regular 2 gives me 150. Radical 2, but here it's actually saying round to the nearest foot, so they do want it in decimal form, so we can just put this in the calculator, and I do not have a calculator with me, so go ahead and put that in the calculator, get your decimal, put it in a box, and since you're a good noodle, put your units, and there you go. All right, and then you've got one last practice problem. Let's pause the video here, work it out, and we'll come back and check it. Ready, go. All right, so this one was a little bit trickier, okay? For my sports people, this might have made more sense to them. My not sports people were probably like, what is going on here? Okay, so if you don't know, a baseball field, okay, all the bases, okay, I'm gonna let all these little right angle boxes be the bases to a baseball field. Together they all make a square, right? And it's a 90 by 90 square, so all these sides are 90. Okay, so this is home plate, this is first base, this is second base, this is third base. Okay, they said find the distance from the second baseman. Okay, so second baseman usually plays around second base, so if he's here on the base, that he has to throw the ball in order to get it to home plate at to the catcher. So he's throwing the ball straight across here. Okay, so we want to know what's the distance of that throw. Okay, well, if we know the distance between the bases is 90, then that distance, right, since this is a 45, 45, 90 right triangle, since we just cut a perfect square, we are just going to multiply, right? We're going to save ourselves the trouble of doing Pythagorean theorem, and just multiply 90 times radical 2. Okay, once again, I don't have a calculator with me, so put that in the calculator. Just put 90 radical 2, press enter. You'll get your answer. Put it in a little box and put your units. Just check and see if everybody's got the same answer. We should. And that is it for today's notes. Awesome job, y'all. I hope you have a wonderful weekend, and I'll see y'all Monday.